Question 1. We have a chord of length 48 centimeter is at a distance of 10 centimeter from the center of the circle. Now if you see in the first statement, they have given you the length of the chord and they have also given you the distance of the chord. So let us consider this circle with center O and let this be the length of the chord given. So let us name this chord as AB. So they have given us length of this chord AB as 48 centimeter. And then they have also given us the distance of the chord from the center. Now remember, distance of the chord from the center always means perpendicular distance. So we will drop a perpendicular on this chord and this perpendicular will be known as the distance of chord, which is given to you as 10 centimeter. Now let us name this perpendicular as OM. Now we have a property that whenever we drop a perpendicular on a chord, perpendicular from center always bisects the chord. So here you can see OM is perpendicular on chord AB. Therefore, OM bisects AB. You must be knowing this theorem that whenever you drop a perpendicular from center onto the chord, then that perpendicular will always bisect the chord. So here OM is perpendicular to chord, so OM bisects AB. So if OM is bisecting AB, so we can say that AM is equal to MB. These two parts will be equal, so it will be 48 upon 2, that is 24. So we have got this part as 24. Now what we will do, we will join OB to get a right angle triangle. So let's join OB to get a right angle triangle. Now you can see in triangle OMB, as triangle OMB is a right angle triangle, so we can apply Pythagoras theorem. Opposite to 90 we have radius, which is unknown to us. This is radius that is unknown to us. Then we have perpendicular as 10, base as 24. So from here we can get radius. So we are getting radius as 26 centimeter. So this will be the radius. Now what the second part says, the second part says another chord of length 20 centimeter is drawn in the same circle. Now in the same circle you have to draw another chord. So let us draw another chord in the same circle and we will name this chord as CD. Now the length of this chord is 20. So let us mark the length of this chord as 20. Now the question says you have to find its distance from the center. Now remember, distance of a chord from the center will always mean perpendicular distance. So again we will be dropping a perpendicular on this chord. And we will name this perpendicular as ON. Now remember, whenever a perpendicular is dropped on a chord from the center, it always bisects the chord. That is the theorem. So here you can see ON is perpendicular on chord CD. Therefore, ON bisects CD. So we can say CN is equal to ND, that is, it will be half of 20, that is 10. So these two parts, they will be of 10 centimeter each. Now what we will do, we will join OC to get another right angle triangle. So let's join OC. So you are getting another right angle triangle OCN. Now let us apply Pythagoras theorem in this triangle OCN. So triangle OCN. It's a right angle triangle. So we will apply the Pythagoras theorem. Now in this right angle triangle OCN, OC is the radius, right? OC is radius, and radius we have already calculated in the first part as 26. This is 26. So here in this right angle triangle, this radius is acting as hypotenuse. Perpendicular is ON. Yeah, here perpendicular ON means distance of the chord, and the question says you have to find the distance of the chord. Base will be 10. So this will give you 676. This will become 100, so you will subtract it. So you are getting ON square is equal to 576. So ON is equal to under root of 576. That will give you 24 centimeter. So we have got ON, and what was ON? It was the distance of the second chord from the center. So this they have asked you to calculate the distance of second chord from the center. Question 2. In a circle of radius 17 centimeter, two parallel chords of length 30 and 16 are drawn. We have to find the distance between the chords if both the chords are on the opposite side of the center. Let us consider O as the center of the circle. Now we have to draw two chords, and in case 1, the two chords to be drawn on the opposite side of the center. Now remember, when we are drawing two chords in a circle, the chord which is greater in length will be close to the center, and the one which is smaller in length will be far from the center. So two chords, one is 30, one is 16. These two chords are to be drawn in this circle. So let us draw chord of 30 centimeter. Now this chord of 30 centimeter will be drawn close to the center, and the one which is 16 will be drawn far from the center. See, so chord AB, which is greater in length, this chord is of 30 centimeter. Chord CD, which is smaller in length, it is of 16 centimeter. Now these two chords have been drawn on the opposite side of the center. Now the question says you have to find the distance of these two chords. So what we will do, from the center here, we will draw perpendicular on both the chords. We are going to draw perpendicular on both the chords. Let the perpendicular on the first chord AB be named as OM, and the perpendicular on the second chord be named as ON. Now you must be knowing the theorem that whenever we drop a perpendicular from the center onto the chord, it always bisects the chord. So as you can see in this diagram, that this OM is perpendicular to the chord AB. Therefore OM bisects AB. So if AB is bisected, so we can say AM is equal to MB, and both will be half of 30, that is 15 centimeter. So this chord AB, after being bisected, its two parts will be 15 centimeter each. Similarly, you are dropping perpendicular from center on the chord CD. So chord CD will also be bisected. So ON is perpendicular to chord CD. So therefore ON bisects CD. So you can say CN is equal to ND is equal to 16 by 2. That will give you 8 centimeter. So they will be of 8 centimeter. Now what we will do, we will complete a right angle triangle with this chord first of all. So OMB is a right angle triangle. So we can say in triangle OMB, as you can see OMB is a right angle triangle, so we can apply the Pythagoras theorem. So we will apply Pythagoras theorem here. So here hypotenuse will be this side, that is the radius. So radius square is equal to perpendicular square, that is OM plus base square, which is 15. Now here radius, as you can see, is already given in the question 17. OM, that is the perpendicular distance, it's unknown to us. Then we have 15 square 225. This will become 289. You subtract 225, you will get OM square. So OM square is equal to 64. So OM is equal to 8 centimeter. Now we will draw right angle triangle with the other chord also, that is triangle OCN. In triangle OCN, it's again a right angle triangle. This is a radius, so we are going to apply the Pythagoras theorem. Hypotenuse is radius, perpendicular is ON, and base is 8. This will be 17 square. This will be subtracted this side, ON square. So 289 minus 64. So this will give you 225. So ON will be under root of 225. That will give you 15. Now see, we have got OM, we have got ON. Question says you have to find MN, that is the distance between the two chords. So MN will be equal to OM plus ON. See, OM plus ON, that will give you the distance between the two chords. So 8 plus 15, so that will give you 23 centimeter. So in the first part, the two chords were to be drawn on the opposite side. So when the two chords are drawn on the opposite side of the center, the distance between the two chords will be 23. Now moving on to the second part, they say that the two chords are on the same side of the center. And the second part, the two chords to be drawn on the same side. Now we are going to draw the two chords on the same side. Now the longer chord will be close to the center and the smaller one will be far from the center. Longer chord AB, as the question says that the longer chord is of length. The length of the longer chord, you can see it's given as 30 and the smaller one as 16. So what we will do, we will draw perpendicular on these two chords. See, Perpendicular on the longer chord will be named as OM, and the perpendicular on the smaller chord will be known as ON. Now this MN is the distance between the two chords. Now this longer chord, which is of 30 centimeter, will be divided in two parts, and the smaller chord 16 will be divided in two equal parts. So this will become 15, 15. This will become 8, 8. Now we will complete a right angle triangle with the longer chord. When you are completing the right angle triangle, then this OA is the radius, that is 17. So again you can do the same calculation in triangle OAM. Triangle OAM. It's a right angle triangle. Hypotenuse is 17. Perpendicular is OM. Base is 15. This will become minus 225. You will get the same values as you got in the previous calculations. Same values. Now we will form a right angle triangle with the chord CD. See here, we will join OC, and we will get another right angle triangle. In this right angle triangle, OC is the radius, which is 17. So let us consider triangle OCN. Radius is the hypotenuse. Perpendicular is ON, and base is 8. So it's 289 minus 64. So ON square is equal to 225. So ON is equal to under root of 225. That will give you 15 centimeter. So you have got OM, you have got ON. According to the question, we need distance between the two chords, that is MN. So to get MN, from ON you will subtract OM. ON you have calculated 15. OM you have calculated 8. So 15 minus 8, that will give you 7 centimeter. Same calculations we got because the same measurements were there. Only the difference is in this time the two chords are on the same side, so their distance will be subtracted. In question number 3, the parallel chords are drawn, should be two parallel chords. Two parallel chords are drawn in a circle of diameter 30. As the diameter is given, so from here you can get the radius. So the radius will be 15 centimeter. The length of one chord is 24 and the distance between the two chords is 21. You have to find the length of the other chord. Now one very important thing is they have given you distance between the two chords. Distance between two chords. Is equal to 21. Now remember, whenever the distance between the two chords is greater than the radius, then the two chords cannot be on the same side of the center. Once again I'm telling you, if the distance between the two chords is more than the radius, then the two chords cannot be drawn on the same side of the center. If this is the center, you cannot draw the two chords on the same side if distance between the chords is more than the radius. So what we will draw, two chords on the opposite side. one chord AB, the other chord CD. Length of one chord is known to us, it is 24, and we need to calculate the length of second chord. Now what we will do, we will draw perpendicular on the two chords from the center. Perpendicular on the first chord and then perpendicular on the second chord. So OM is perpendicular on the first chord, ON is the perpendicular on the second chord. Now we know the theorem that whenever we drop a perpendicular on a chord, it bisects the chord. So this chord AB, which is of 24 centimeter, will be bisected as 12 and 12. So we will mention it here. OM is perpendicular to AB. So OM bisects AB. So we can say AM is equal to MB. That will be half of 24, that is 12 centimeter. Similarly, we are dropping a perpendicular on the second chord CD. So this second perpendicular, that is ON, it is perpendicular to chord CD. So ON bisects CD. So you can say CN is equal to ND. CN is equal to ND. That is equal to, now length of CD is unknown, but we have got to know that these two parts will be equal, so let them be marked as X. Okay, now very important thing is distance between the two chords is given as 21. This distance MN is given as 21. So what we can do, we can consider this distance OM as Y. Let OM be considered as Y. The total distance is 21. So ON will be 21 minus Y. See, total distance is 21. Out of 21, if we consider this portion as Y, so the remaining will be 21 minus Y. Now let's get the two right triangles. First of all, we will get the right triangle. OAM. It's a right angle triangle, and this OM, this is the radius, and the radius is known to us as 15. Then we will get a right angle triangle here. Now here OC is the radius and radius is 15. Now let's solve the triangle AOM. It's a right angle triangle, you can see AOM. So in triangle AOM, we will be applying the Pythagoras theorem. Hypotenuse is this radius 15. Perpendicular is OM, that is Y. Base is 12. So this will give you 225 minus 12 square will give you 144. So this will give you 81. So Y is equal to 9 centimeter. So we have got distance of the first chord from the center. So the distance of first chord from the center is 9. Now let us consider the other right angle triangle. The other right angle triangle is OCN. Triangle OCN. Let's apply Pythagoras theorem in this right angle triangle. So here when we apply the hypotenuse is 15. Perpendicular is 21 minus Y. and base, this is x. Right? Now this will give you 225. Now within the bracket 21 minus y is known to us as 9, so this will be 21 minus 9, so that will give you 12. So from 21 you will subtract 9 and you will get 12. So it's 225 minus 144. So x square is equal to, so x is equal to 9. So we have got from 225, this was 21 minus y. So y is 9. So you are going to subtract 9 from here. So from 21, if you subtract 9, you are getting 12. X is equal to 9. Okay. So you have got x is equal to 9. Now you have to calculate the length of the chord CD. As you can see, the length of chord CD will be x plus x. So length of chord CD is equal to x plus x. So that will give you 9 plus 9, 18 centimeter. This will be the length of second chord. Question number 4. Question number 4 says the diameter AB is the diameter, and diameter AB is bisecting the chord CD at E. Now if you see the diagram, here in the diagram you can see that chord CD is being bisected by a line coming through the center. And we have a theorem that a straight line drawn from the center to bisect a chord is always perpendicular to the chord. So here you can say OE, it is a line from the center, it is bisecting the chord. And the theorem says a line from the center which is bisecting the chord is always perpendicular to the chord. Therefore OE is perpendicular to CD. This is a theorem, right? So here you can write the theorem then. See, the theorem was a straight line drawn from the center of a circle to bisect a chord is at right angle to the chord. So here you can mark this angle as 90, right? Okay, now EB is given as 4. This portion EB is 4. CE is equal to ED. This is 8. This is also 8. Now we will join OC to get a right angle triangle. Let's join OC to get a right angle triangle OEC. Now you can see OC is the radius, and the question says you have to find the radius. Now considering triangle OEC. Now first of all you consider OB. What is OB representing in this figure? You see OB. What is OB representing? OB is radius, right? Center to circumference. OB is radius. Now OB can be written as OE plus EB. Now EB is known to you as 4. So from here you have got OE as R minus 4. OE is R minus 4. So we can write OE as R minus 4. Now let us solve this right angle triangle OEC. Triangle OEC. We have hypotenuse square is equal to perpendicular square plus base square. Hypotenuse will be this side opposite to 90, R square. Perpendicular will be this, R minus 4, and base will be this 8 square. Now when you open this bracket with the formula a minus b whole square, you will be getting R square plus 16 minus 2 into a into b plus 64. R square will cancel out. This will become minus 8R. You will transfer it this side, so plus 8R. On the right side 16 plus 64, that will give you 80. So R is equal to 80 by 8. So that will be 10 centimeter. So the radius will be 10 centimeter. See, this is clear to you?